SwayamPrabha. Digital India. Educated India.
Welcome back. In module 6, we will be talking about water quality testing and treatment, and in lecture 26, we will be starting with water quality and testing part 1. So, the different concepts that we will cover in this lecture are on potable water, impurities in water, physical and chemical quality of drinking water, bacteriological guidelines, recommended treatment for various water sources, and sampling procedures for testing. Now, when we talk about potable water has the characteristics of both wholesome water and palatable water. Now, palatable water is basically what is tasteful for drinking and aesthetically more pure, and this is what is called palatable water. But wholesome water is water from which impurities have been removed, so that it is not harmful to public health. And so, potable water is both wholesome water as well as it should be palatable. So, even though we remove most of the impurities from water, but we retain certain elements, because not everything needs to be removed, not everything is harmful. But when we talk about impurities, at least we should be removing all the disease causing bacteria, and we should make sure that the whatever treatment or the water that we are consuming should be colorless, sparkling and acceptable, and it should be tasty, odor free and cool. That means it should not be very hot as well, heated as well. It should not corrode pipes. This is important for the different transmission pipelines or the treatment units, and should be free from objectionable matter, and should have dissolved oxygen and free carbonic acid, so that it remains fresh. So, that means both the properties of wholesome water and palatable water, if both are present, then we can call it potable water. Now, why do we need to understand about these impurities in water? Because water, whenever we are going for planning in an urban area, we need to understand the different sources of water and what kind of source it is, and based on that we have a fair idea about what kind of impurities would be present in that kind of water. For example, if we test water in rural areas, we will see that there is lot of fecal coliform bacteria in that particular water. So, but we need to make sure that this the levels are not up to that level which will actually harm us, right? But before we get into that, we first need to understand what kind of impurities could be there in water. Some of them may be harmful, some of they are not, some of they impart certain characteristics to water, like for example, presence of certain impurities will change the color of water, but it has not got any other harmful. But even we shouldn't have the water which we drink should not have any color in it, or should have very little amounts of color. So, this kind of that is the reason we first need to understand what kind of impurities are there in water. So, the water which contains undesirable impurities is known as polluted water, and we usually called water containing pathogenic organisms as contaminated water. So, polluted water, contaminated water, these are the ones which we need to actually be worried of. So, what kind of impurities are there? There are different types of impurities. First, I will group them into three kinds. The first is suspended impurities. These are basically solid particles which are pretty large, that means 0 to around 10 to the power minus 3 millimeter in size. It is not 0 actually, we have 1 to 10 to the power minus 3 millimeter in size, and this kind of impurities could be removed through filtration. right. So, that means if we use a filter, then we can pass the water through a filter, any form of filter, and then it would be actually able to remove this kind of particles, because these are pretty large, they will get stuck in the holes of the filter. So, some of these particles could actually settle down because of their own weight. That means, because their specific gravity is higher than that of water, if we just keep it in a particular space, they will actually separate. And so but because in some cases the specific gravity is not that high for some of these particles, they will remain mixed with water, such as clay, algae, fungi, organic and inorganic, some amount of organic and inorganic matter. And this overall, the amount of these suspended impurities could be measured by their concentration, which is measured by its turbidity, which is measured by turbidity of water. So, if we can measure the turbidity of water, we can understand the total amount of suspended impurities in that. So, as we just discussed, so total suspended impurities could be removed either through sedimentation or through filtration. So, these are the two ways we have to remove that. And this kind, based on this particular and then in a particular source of water, there could be different kinds of impurities, and accordingly we have to determine what kind of treatment has to be taken for this kind of water based on the kind of impurities that are there. So, if there are heavy particles, then we have to go for sedimentation, or if there are smaller particles, then we have to go for filtration, and so on. Then comes the colloidal impurities. These are, as we have discussed, like 1 to 10 to the power minus 3 millimeter in size are the suspended impurities. Colloidal impurities are even smaller than that. This cannot be removed by ordinary filters, and so there has to be some other way. So, what we do is we do chemical coagulation. That means, we add some chemicals into the water, and these actually react with these particular particles, and then they form some other compounds which are larger in size, and that is what we can actually remove. And colloidal impurities are electrically charged. That means, they have absorbed ions on the surface, which is either positive or negative, and because of these charges they repel each other, and because their mass is not that high, they are able to repel each other, and this results in continuous motion of these particles inside the liquid, and that actually makes it difficult to separate. So, that is why we have to go for chemical coagulation. Continuing on the properties of colloidal impurities, some amount of color is imparted because of these colloids, and this could be determined by the color test, and the sizes are 10 to the power minus 3 to 10 to the power minus 6 microns meters, and 1 micron to 1 millimicron, and acid, and it contains both acid and neutral materials like silica and glass. This gives a negative charge, and it can also contain basic materials such as metallic oxide, which gives it a positive charge. So, organic matter containing bacteria could be also present as colloids, and this can cause epidemics. So, that is why we have to be very careful about colloids as well. Finally, we have got dissolved impurities. So, dissolved impurities could be solids, liquids, gases, but it which usually whenever water flows in a natural environment, all these gases gets dissolved into that, and this concentration of dissolved solid could be expressed in parts per million. So, this is the unit that we will use repetitively later on, and this can be obtained by weighing the residue after evaporation from a filtered sample. So, this we have learned it even in our 10+2 classes. That means, if I keep on boiling water, the water will evaporate, and then whatever is left is the and if we do it after this is the total
sample that would be left, and that will contain both organic and inorganic materials, and gases will not remain. So, all the dissolved impurities could be got rid in this particular way, and all the evaporated water could be again actually we can actually again this steam could be converted into liquid as well. So, this filtered this dissolved impurities, if we after doing chemical coagulation and after doing sedimentation and filtration and chemical coagulation, then if we then do this kind of evaporation, then we are left with only the dissolved impurities, right. All the other impurities are already taken care of earlier.
or we can just do evaporation, we can get rid of the entire quantity of water that is there. Both all different kinds of impurities could be removed. So, the Central Public Health and Environmental Engineering Organization in India, that is CPHEEO, and they have given us the standards for acceptable limits of different properties of water, that is for drinking purpose. That means for drinking water, it has to have certain characteristics which has to be within certain standards or certain limits. In some cases, higher values are tolerated, but that means it depends on from case to case. So, as you can see in the first figure, we have given acceptable, and the second figure, then there are 2 stars, which is cases for rejection. So, under acceptable column are limits up to which water is acceptable to consumers. Figures above these values may be tolerated in certain cases, but up to the levels given in this second column. That means only if this is not possible in certain cases, we will look into the second levels. All right. So, let us look into certain values, like for example, turbidity is measured using NTU, we will discuss that later, and this 1 unit is acceptable, whereas 10 unit is the maximum limit in certain cases. Color of the water, this units on a platinum cobalt scale, again we will discuss it later. So, 5 levels is acceptable, 25 is the case when we can reject it. Taste and odor, this has to be, there has to be no objection in regards to that, and similarly pH values 7 to 8.5 is acceptable, whereas lesser than 6.5 or higher than 9.2 is not acceptable at all. Total dissolved solids maximum 500 in milligrams per liter acceptable, and 2000 is the maximum limit in any other case, and so on. So, we have total hardness. We will discuss all these terms later on, what exactly this means, but we have but some of this you have already learned earlier. Then we have got chlorides. Chlorides is basically sodium chloride or salt present in water. Sulfates, presence of sulfate, fluorides, nitrates, calcium, magnesium, iron, manganese, copper, aluminum, and so on, right. But we are not able to see those the harmful ones. Where is arsenic? Where is lead? Where are those values, right? Let us look. So, here we see all the ones which are acceptable limits are my very limited values. These are the harmful ones: arsenic, cadmium, chromium, cyanides, lead, selenium, mercury, then some amount of pesticides, polynuclear aromatic hydrocarbons. So, these are the ones which we should be very, very careful about, and as you can see, both the first column and the second column shows similar values, which is around 0.1 for arsenic milligrams per liter, 0.01 same for cadmium, 0.05 for chromium as hexavalent chromium. So, these are the ones which create cancers, these are the ones create different kind of diseases, and so on. So, we need to be very, very careful about this kind of this kind of constituents of drinking water. Similarly, we also test for radioactivity in some cases, like for example, in some mines and spring water, sometimes we find radioactivity, and we need to analyze the limits for radioactivity, and individual radionuclides has to be assessed, and we see that the gross alpha activity is becquerel. This unit BQ by L is given in the maximum limit is 0.1. And this gross beta activity is alpha activity and beta activity. These are the 2 things that are measured when we measure for radioactivity. So, basically these are the standards which have been specified by the government of India, that this should be the limit. So, what it means is, whenever we are treating water, at the end of that we should test the water, so that the water is actually conformed to these particular limits. Or in case we are using certain groundwater directly and all, we should check that these are the limits that has been adhered to. So, in addition to all these chemical constituents, we also have got guidelines in regards to bacteriological in case of bacteria, and these guidelines are again more or less you can see that most of these bacteria that are listed are not this should not be detectable. For example, as you can see that E. coli or thermotolerant coliform bacteria, this must not be detectable in any 100 milliliter sample. Why it is so? E. coli or coliform bacteria, these are basically E. coli is a kind of coliform bacteria, and these are coliform bacteria usually is present in fecal matter. And when you find this kind of bacteria, when you can test for and find this kind of bacteria in water, you can understand that there is fecal contamination of water, right? And what it means is there would be other pathogenic bacteria in water which would be actually harmful for you. Even though coliform itself is not harmful, but their presence indicates presence of other harmful bacteria. So that is why we need to make sure that these are not detected at all. So there are three kinds of standards have been mentioned. One is water intended for drinking. One is treated water entering the distribution system. That means once the water is treated, it is put into the pipeline. Then there also we make sure that neither total coliform or E. coli is being detected in 100 milliliter samples. Then there is treated water in the distribution system. This is water that is getting in the system after treatment. This is water at different points in the distribution system, because what happens, there could be contamination in the pipeline. That means in certain cases there may be leakages, and that is where sewage may be getting mixed with the pipeline. So that is why we also have to test the water quality at different points in the distribution network, and there also we should not be detecting any E. coli or thermotolerant coliform bacteria. But total coliform bacteria, there is a little change, even though it should not be detectable in 100 milliliter samples. In case of large supplies where sufficient samples are examined, must not present in 95% of the samples taken throughout any 12-month period. So that is the standard that is specified by CPHEO. So usually when E. coli is detected, then we go for repeat sampling, and E. coli is a better indicator than the count of thermotolerant coliform, but both are acceptable. And in rural untreated water supplies, total coliform is not an acceptable indicator. I was talking about this in my earlier lectures, where we stated that when we have got in rural water supply, there is a lot of fecal contamination. So total coliform count would be there, right? So if I take that as an indicator, then none of the water supplies could be of any use, right? So we have to understand that rural water areas, we cannot expect that suddenly we will have very, very clean water. So there will be progressive improvement of water quality in rural areas. So that's why the standards are kept lower, and drinking water, but that means total coliform can be there to some extent, but again E. coli should not be there, and drinking water should be treated to make sure negligible amount of enteroviruses are there. So, but we should make sure that there are no enteroviruses in the drinking water supply in rural areas, of course. Now, whenever there are, as we are discussing that there are standards for drinking water supply both for urban and rural areas, but whenever we are going for when we are planning for a certain area, we need to actually understand what kind of source it is, and we have to recommend some kind of treatment, right? Sometimes the area is maybe cut off from the other habitations, so this is an independent area. We need to really decide on what kind of treatment could be given, right? So in that case, we should understand that for different types of water, like based on the sources. For example, if it is a groundwater, like protected deep wells, essentially free from fecal contamination, in this case, we can suggest that this water could be directly taken up just with disinfection. That means you mix chlorine with water and you can drink it, right? Unprotected shallow wells, and there is some amount of fecal contamination, then we better go for filtration and then disinfection. So not direct disinfection will work for this. Similarly, for surface water sources, if it's a protected impounded upland water, upland water is basically the water channel at levels which are above the sea level, where we at higher levels of the stream, and it is an impounded reservoir, and there is no chance of fecal contamination over there because it's sort of a dam. So there also we can drink the water with disinfection. But if downstream, that is if it is unprotected impounded water or upland river and fecal contamination is happening, if it is not protected, then we have to go for filtration and disinfection. But if it is unprotected lowland rivers and fecal contamination there, we have to go for further treatment. That means we have to go for pre-disinfection, then we have to store the water, then filtration, then disinfection, right. Then unprotected watersheds with heavy fecal contamination, we have to go for filtration, and then we have to pre-disinfection, then additional treatments could be also required for. And same goes for the unprotected watersheds grows with lot of fecal contamination. And usually these are not recommended for drinking water supply, but sometimes we really, in case there are no other sources, we have to treat it. So, so for more or less all sources, the median value for turbidity before final disinfection, that means these are the basic bacteriological, from the perspective we are saying this kind of treatment should be given, but we also need to test for turbidity before the final disinfection, and we should make sure it is less than 1 NTU, which is nephelometric turbidity unit, and less than 5 NTU in a single sample. That means if we just take one sample, then it should be less than 5 NTU, but if we take multiple samples, overall it should be less than 1 NTU. Then terminal disinfection, that is some amount of chlorine has to be given for disinfection and some amount of chlorine has to be left, which is called the residual concentration of chlorine or free chlorine, right. So this value is around, it should be greater than 0.5 milligram per liter after 30 minutes of contact in water at pH of lesser than 8. So that means some amount of residual chlorine has to be there, so that during the distribution process and all, there is chance of contamination, and this residual chlorine will actually give protection. Then filtration refers to slow filtration or rapid filtration preceded by coagulation and flocculation. That means we need to do chemical coagulation before we do filtration. And we can also go for additional treatment, which is slow sand filtration, ozonation, then using activated carbon absorption of certain gases and all. So this could be also taken up as additional treatment. So these are the different kind of treatments that we can suggest for different water sources. Now finally we come to sampling procedures for testing. Now we can do testing in a laboratory environment, but whenever we, like for example, when we go to field for conducting surveys for a particular urban areas, we conduct different kind of surveys. We conduct household surveys, we conduct traffic surveys. Similarly, we also collect samples of water from different kind of sources to understand different things, to understand water quality, to understand like for example contamination of certain water bodies. Like for example, we want to test if sewage is mixing with certain lakes, right. So we will take samples from the lakes to understand if sewage is getting mixed with that, right. And so for that, based on, we also need to conduct different tests, and we also, if certain areas there is no water treatment unit, we need to recommend a sort of treatment for a particular water body which people use for drinking and other purposes. So that is where we need to test the quality of water. We also need to test the quality of water from the distribution network to understand the quality of the distribution network. If there is some contamination happening within that, if there are leakages within that network and so on. So that is why some amount of testing has to be done at the field level and some amount of testing has to be done immediately. That means immediately means as soon as the test is done, that sample is collected, we need to test it, right. So this kind of test actually confirms the physical, chemical and the bacteriological properties of this particular water. And as we know that the physical analysis actually helps us to understand the aesthetic quality and other physical parameters that is relevant for treatment eventually. Then chemical analysis gives us an idea about what kind of chemical substances are there inside the water, and this indicate, some of them indicate different kinds of pollution, and also we can suggest different kind of treatment processes for that. And bacteriological examination is primarily for assess the safety of that water for consumption purposes. and biological examination is for basically which causes of objectionable taste and odors in water and clogging of filters. So, we need to also check for biological contaminants like some matter getting decomposed and that is present inside this particular water body and so on. So, organic matter or decomposing organic matter has to be also tested for, and bacteria is mainly for different health issues that may arise out of that. That is why we also need to test for bacteria. So, how do I sample? So, water sampling of water has to be done carefully and has to be done following certain procedures. Otherwise, we will just we will get results from testing which would be not based on the actual water that we are testing, but based on other things, based on what was there already in that bottle or based on the material of that bottle that we are using and so on, right. So, for sampling we need to make certain, need to follow certain standards, and suppose whenever a team goes to a field for survey, they need to carry this kind of, they need to follow this kind of steps, as well as they need to follow this kind of containers along with them, right. So, first of all, whenever you do sampling, sampling has to be representative. That means it should represent the water that we are testing, date, time of collection, type of source of the sample, temperature of water at time of collection, all these things has to be recorded. Samples for bacteriological test are taken first, proper packing and separate compartment for each bottle, containers of inert materials of Pyrex glass or polythene so that it does not react with the water, cleaning a bottle using chromic acid cleaning mixture and then with tap water and finally with distilled water. So, before we even take the bottles, we have to do a basic cleaning, so that we first clean it with chromic acid, then with tap water and finally with distilled water. So, then this sample bottles are ready. Now, what amount of samples? 2.5 liters from each area wherever you are collecting water, you need to collect 2.5 liters of sample is required, and the bottle has to be rinsed with the water to be, once you have cleaned the bottle like we discussed just now, the bottle, whenever you are collecting the water, the bottle first rinsed with water to be collected, except for the bacteriological analysis. For all other purposes, we need to clean the bottle with the water from which we are collecting, and samples should reach laboratory within 72 hours, and that is very important because certain characteristics will change. Then certain things like temperature, pH, dissolved gases like carbon dioxide, oxygen, hydrogen sulfide, this has to be, it is better to do it on the spot. Nowadays, we have got different sort of meters which we can just put in the water and you will be able to get the results. Samples from well should be collected after it is pumped for sufficient time. That means we are getting the fresh groundwater that is flowing inside the well, that we need to collect. Samples from surface water sources should be collected from 40 to 50 centimeter below the surface to avoid impurities. That means when we are collecting water from a river, we should first put the water, the bottle below the water 40 to 50 centimeter, then only release the, open the mouth of the bottle so that the water gets in. Samples from taps are collected after allowing sufficient quantity of water to pass. So, these are the standard procedures that you should follow whenever you are collecting samples for testing. So, for bacterial analysis, we need to be a little bit more careful. We use sterilized glass bottles in most cases, and this should also have glass stoppers. So, you can see this is a glass stopper and a glass bottle. And sometimes if there is, we are testing for chlorinated water, that is treated water, we need to dechlorinate it first, and for that we use certain sodium thiosulfate is before the sterilization process, we use that. Then bottle filled up by holding at base and without rinsing, as I was mentioning earlier, that we don't rinse it with the water source from which we are collecting, we just hold it at base to collect the water. A minimum volume size is 250 ml, which is unlike the 2.5 liter that we need to collect for other tests. And analysis is done if it is beyond 24 hours, then we have to preserve it in ice till a maximum of 72 hours. After 72 hours, we have to just throw away the sample. So, every test has to be done within 72 hours. So, sampling procedure, frequency of sampling depends on what water we are testing. the treatment process that is there and the local context. Sampling has to be done for both raw water and treated water to see what kind of difference is happening, and to understand the baseline as well. And bacteriological sampling has to be conducted at different parts of the water supply system to understand that if the leakage is happening the leakage can happen at any point. So, until unless we test the water at different points, we won't be able to understand where leakage is happening also and what kind of contamination it is resulting in. So, this table gives you the minimum sampling frequency as per Indian standards for distribution system. Like if it's for larger population, like we have got for 100,000 people, then every day the sample has to be taken, and one sample for every 10,000 of population per month. For population 50,000 to 1 lakh, every 4 days we need to take samples, and one sample per 5,000 of population per month, and so on. So, so you can understand that in water treatment plants, we usually have a laboratory also where they do that all this testing and all. But in addition, the utility provider should also test the water quality in the distribution network. And sometimes as planners also, we need to do this test to understand the situation in that particular network, because sometimes those kind of information may not be provided by the utility providers. So, that is where urban planners should also be ready to test this kind of, take this kind of samples and test, do some amount of test for this kind of water. So, to conclude, water contain various types of impurities which needs to be tested against physical, chemical and bacteriological standards and guidelines to determine its quality. And water needs to be treated to make it potable, and sample collection for testing has to be done following strict guidelines of safety. So, these are the references. Thank you.